as we have already discussed about wideband frequency modulation, whose power is power of carrier, which is nothing but AC square by 2. We will now discuss about multi-tone wideband frequency modulation, where two frequencies are considered to be frequency modulated. So here, following the same procedure which we followed for wideband frequency modulation, we consider two different frequencies, P of t equal to AM cos 2 pi f1 t, V2 of t is equal to AM cos 2 pi f2 t. If you consider two different frequencies, similar to wideband frequency modulation, what we discussed before, we will get two different periodic functions. One is S1 bar of t and the other is S2 bar of t. So by applying Fourier series, we are going to get an equation which is applied for multi-tone frequency modulation. So finally we will get S of t is equal to AC summation minus infinity to infinity Jn of beta, which is nothing but Bessel function, S1 of t into S2 cos of 2 pi into Fc plus m f1 plus n f2 into t. Since we consider two different frequencies, f1 and f2 are two different frequencies, what we consider, m and n are two integers. So finally here we are going to have cross modulation terms, because if m is 0, you are going to have Fc plus mf2. If n is 0, you are going to have Fc plus mf1. So when you have both the terms, you have zero crossings. That's, you get same terms twice, thrice or many times. So you have cross modulation in case of multi-tone frequency modulation. And in frequency modulation, we have non-linear process. Due to the effect of this zero modulation terms, we are going to have non-linear modulation process here. So in order to find the bandwidths of narrowband frequency modulation and wideband frequency modulation, we follow certain rules. In case of narrowband frequency modulation, we know that experimentally it's found that beta should be less than or equal to 0.3 in order to overcome the distortions. So here, bandwidth is considered to be 2fm, where fm is frequency of modulated wave. Whereas in case of wideband frequency modulation, where beta is greater than 1, we follow two different rules to define the bandwidth. One is Carson's rule and other is universal rule. According to Carson's rule, bandwidth is equal to 2 into delta f plus fm. But according to universal rule, bandwidth is equal to 2 n max into fm. Now according to universal rule, we know that bandwidth is 2 into n max into fm. Now we'll define a table to determine this 2n max value depending on the value of beta. So now we'll draw a table which decides the value of 2n max depending on modulation index value. From this table you can substitute directly and get the bandwidth. If beta is 0.1, 2n max value is 2. If beta is 0.3, 2n max value is 4. Now from this table you can get the values of 2n max. If you for a given beta value, if you substitute these values, you will get the bandwidth. And for beta value of 0.5, you are going to have 2n max value is equal to 4. This is most widely used value. Similar to beta, which is modulation index, we will define now a term which is nothing but deviation, which is equal to delta f by w. It plays the same role played by beta, which is nothing but modulation index.